Hello, everyone, and welcome back to this series of lectures on how to address claims scientifically. Um, so again, I would like to highly recommend that you follow the sequence of these lectures. And if you haven't watched the first two lectures, please do. Because in order for you to understand the concepts that we will discuss today, you will need to listen to the first two lectures. So today's lecture, I would say, is actually the core of this course. It contains the approach that we're going to use to refute any claim. And also, today's lecture will be a little bit shorter and more focused compared to the previous two lectures. So before we go to the core of this lecture, let's just recap from the last two lectures. So in the first two lectures, we had an introduction to what science means and how science evolved from deduction to induction, and what is the scientific method. And we defined the different characteristics of science and the scientific method. We also discussed how we know. So in other words, what is knowledge and how do we acquire knowledge? And the latest thing we discussed was the different types of evidence. And we talked about ranking from the weakest kind of evidence to the strongest kind of scientific evidence. So today we're going to focus on one approach on how to critically appraise claims. This approach is called FiLCHeRS, as each capital letter indicates a specific word, which we will discuss in the next few slides. This is an approach, it's a tool that you can use. There's different tools that you can use to refute claims, but this is one that was published by James Lett, and I recommend you follow this as well. So FiLCHeRS, the F stands for falsifiability. We will define each one of these words later on in details. L is for logic, C is for comprehensiveness, H is for honesty, R is for replicability, and S is for sufficiency. So falsifiability. So it must be possible to conceive of evidence that would prove the claim false. We have talked about this concept as well in the first two lectures, and we mentioned that this is a core feature of the modern science, where when you start with a theory, the modern science tells us that the theory must be falsifiable. And that is why we come up with probabilities and p-values and confidence intervals, because there is a limit below which we will reject the null hypothesis and we will say that this theory is false or the conclusion is false. So the rule of falsifiability guarantees that if the claim is false, the evidence will prove it false. And if the claim is true, the evidence will not disprove it. And again, as we discussed before, you cannot prove anything. So you can disprove, and if you're not able to disprove, then you can tentatively accept it as a truth and move on. So you will accept a certain theory as true until you get another study that disprove it. If you do multiple studies and you cannot disprove this concept, then most likely this concept is true. Again, I keep reminding myself and yourself about that example that I gave about penguins. Of course, if you do study with 10 penguins, you may not have enough sample size. But if you look at 100 penguins, and your theory is that all penguins are black, then maybe you need to have a larger sample size. And this is basically what studies are trying to do, is maybe sometimes with increasing the sample size, you will be able to disprove your hypothesis. Maybe we will have a chance later on in another course to discuss about the different designs of the studies and sample size, etc. But this is not the topic of today's. So there are a number of ways or statements where you can have non-falsifiable claims. So the first type is the undeclared claim. So this is a statement that it's so broad or vague that it lacks any propositional context. In other words, it's meaningless. So here's a few examples of that. So some people claim that crystals give out resonance of perfection, restore balance and harmony to your spiritual energy. So what does this actually mean? I mean, scientifically, what do you mean by restoring balance and harmony? How do you define harmony in a scientific word? And what do you mean by negative energy or positive energy? What do you mean by spiritual energy? How do you define perfection? How do you actually know that these crystals give you this perfection or balance or harmony? All of these are very broad, vague statements, and they're basically meaningless. Some people in Arabic will say, okay, الأحجار الكريمة تطرد الطاقة السلبية, or it brings the positive energy, or it gets rid of the negative energy. All of these are really meaningless statements. Magnetherapy helps regain self-healing. It gives you electromagnetic balance. So what does that mean? Again, very vague, meaningless statements. People maybe talk about wet cupping that removes bad blood, for example. So what do you mean by bad blood? Is there any scientific definition for bad blood? And how do you remove it separate from good blood? So all of these are non-falsifiable statements, as they are meaningless and vague and broad. If you go to psychic people, so here's a funny cartoon that says, I can't see your future, but luckily I'm very good with vague generalizability and meaningless half-truths. So this is how these people convince you that they are telling you the truth. So the second type of non-falsifiable statements is what we call multiple out. Multiple out means people uses a series of excuses which explains away the evidence that would seem to falsify the claim. In other words, for example, if someone went to a psychic healer and says, I want a treatment for my arthritis, and psychic healer gave that kind of treatment. Later on, they come back to them and they said, well, my arthritis is not getting better. Then basically what they will try to say is that, well, it didn't work for you. This treatment didn't work for you because you have rheumatoid arthritis, and it only works for osteoarthritis and other type of arthritis. Well, this is one thing out, which is rheumatoid arthritis. Another person will come to them and say, okay, I'm not getting better. Well, because you're older than 70 years old or whatever. So they will try to come up with multiple out that will exclude you so that you cannot falsify them. Whenever you want to give them a reason to falsify their claim, they will put you in one of their exclusion. So they will come up with a list of if. It will only benefit you if this and this and this and this and this and this and that. So this sometimes happens in modern science, but that comes from evidence. It comes from studies. So drugs can work in certain subgroup of patients. These information come from studies and from evidence. However, If you don't have evidence or data, and you put a long list of non-falsifiable statements or Fs, then of course this is a non-falsifiable claim. Take for example this advertisement that says this kind of a battery lasts up to 8 times longer. So what does this statement mean? So let's say, for example, I bought this battery, and for example, let's just say it died shorter than what I expected. Then if I would come to ask these people about this statement, they will say, we said up to 8 times. It could be maybe 6 times or 5 times or 4 times. So up to 8 times doesn't mean 8 times. And also the word longer than what? Longer than the same brand or a different brand, or like, how can you falsify this statement? This statement is so general with multiple outs that you cannot actually falsify it, okay? A recent example in our time during the COVID-19 crisis, some people, a lot of people actually, they come out to the media claiming that they found a cure for COVID-19. Okay, and I will share with you one example, then we can discuss together. Okay, so here is one example. I hope I can bring it up. Okay.
رئيس منظمة الطب التكميلي الدولية، عضو في هيئة الغذاء البيولوجي بألمانيا. المقطع الصوتي طبعا أنا صار لي 3 أسابيع وأكثر يعني أحاول أتصل، وصراحة أستغيث، أبي حد يوصلني لوزير الصحة عشان أقدم له ملف خاص ببراءة اختراع خاصة بعلاج الوقاية وعلاج مرض كورونا. الحمد لله جاني اتصال، وزير الصحة اهتم جدا بالموضوع، وأشكر وزير الصحة الدكتور باسل الصباح للاستجابة السريعة جدا، وكلف دكتور. الحمد لله احنا لسه الحين تونا طالعين من الاجتماع، وإن شاء الله راح يتم تسليم الملف لبراءة الاختراع خلاص يبتدون التصنيع إن شاء الله تعالى. والحمد لله تناقشنا وحصل اقتناع، وإن شاء الله راح يؤخذ الملف، راح يكون بإيدين الدكتور باسل الصباح بالكثير قدم إن شاء الله. هذا يخص وزارة الصحة، الدراسات معمولة عليه خالصة، يبتدي التصنيع، والمفروض إنه بسرعة عشان تتشال الكمامات والأكسجين، لأن أنا تعمدت إني في أول صفحة أكتب ليش فيروس كورونا يضرب الرئة بالدرجة الأولى، في أول شيء يبتدي على الرئة، وكتبت تعمدت إني أحطه في أول صفحة في براءة الاختراع عشان بسرعة يصنعون ويرتاحون الناس، يحصل التنفس طبيعي، تتشال ينشال الأكسجين. من يومين حطيت اسمه وغيرت الأوراق كلها، كتبت اسم الدواء وحطيت جنبه Q8، راح يكون كويتي، راح يطلع إن شاء الله من الكويت، هو للعالم كله. أنتم منو قال لكم مشاهديني أحبائي أعزائي، منو قال لكم أني أنا قاصدة فيروس كورونا؟ أنا قاصدة جهة موجودة أو عضو موجود بجسم الإنسان ما حد فكر فيه من أول، ولا حد يقول لي لا ليش ما تتكلمين وليش ما تقولين أنا هذا بحثي وهذا دراسي، أنا ما أقدر أطلع برا.
Okay, so we watched this video together that was that I actually found in this guy's account, and many of you have already watched this before today's lecture. If we take this claim, let's just take it as an example to apply some of our rules. This is a slide that I put in the first lecture actually, and I think just to remind ourselves to be to know these kind of rules when we hear claims. Of course, it is okay to disagree with this person. The person who claimed that she has a cure for COVID-19. It's okay that we disagree with her, of course, scientifically, it's okay to disagree. And just to remind ourselves to be respectful to others. So I'm not going to talk about that person or personally. However, let's just apply some of these information that we learned together. So what kind of evidence that person laid out to us in the media? From 1 to 11, you can choose one of these. I can tell you, for example, it is probably about number 3 or 4. If she's an authority in her specialty, then it will be number 4. If not, then it will be number 3. Because what she's telling us is not a study that is published in a peer-reviewed, trusted journal. It is not an observation made systematically based on data, or it's not an experiment for sure. It's not a randomized clinical trial. So it is a very weak kind of evidence that we hear. The other thing is, if we go back here, falsifiability. So she actually gave us multiple outs. So when she came later on, she said, you know what, I did not say that it will help COVID-19. It will help a specific thing in the body. What that specific thing, we don't know. So it is, first of all, it is actually this first type, which is vagueness, because we don't know what she means. It's undeclared. Why she's not declaring the claim? It's not declared, it's meaningless. The other thing is that she gave us multiple outs. Well, I did not say that it helps with this, however, it might help with this and this and that. So this is an example of how you think about claims and how to refute them. We're now in the first letter of FiLCHeRS approach, which is falsifiability. Moving to another letter, which is L. L is for logic. So any argument offered as evidence in support of any claim must be sound. So an argument is said to be valid if the conclusions follows unavoidably from the premises. So this is a kind of a deduction logic which we discussed before. It is considered to be sound if it is valid and if all the premises are true. As we said before, the conclusion will be valid if the premises are true and they follow unavoidably with necessity from the premises. So in other words, the premises must be true and the conclusion must follow unavoidably from the premises, and then you can say this is a valid conclusion, and if the premises are true and the conclusion is valid, then this is a sound argument. So if you can conceive of any single instance where the premises do not follow, the conclusion do not follow the premises, then this is actually not valid, and of course it's not a sound argument. We gave these two examples for you to remind you. So the first example is not valid, whereas the second example is valid. So the first example, the premise 1, dogs get fleas. Premise 2, Tilly has fleas. Conclusion, Tilly is a dog. The premises are true, but the argument is not valid because the conclusion does not unavoidably follow the premises. Second example, all dogs have fur. Lucas is a dog. Lucas has fur. This is sound. Premises are true and valid. The conclusion and the argument is sound. Take this example. So I put this sentence that we can read together, and then we can break it down into premises and conclusion. So this sentence or claim says, tumor growth depends on angiogenesis, protein in sharp cartilage, which inhibits angiogenesis. This protein will prevent and treat cancer in humans. So this claim says that the tumor growth depends on angiogenesis, and there is a protein in sharp cartilage that you can use to help cancer, since cancer depends on angiogenesis. So what are the premises in this claim? The premise number 1 is tumor growth depends on angiogenesis. Number 2, protein in sharp cartilage, which inhibits angiogenesis. can be used to prevent untreated cancer. The conclusion from this claim is that shark cartilage taken orally protects untreated cancer. However, are these premises true and the conclusion is valid? Well, sharks actually do get cancers. A handful of numbers of cancers can develop in sharks. So the premise is not true. The first premise is not true. Not all cancer rely on angiogenesis. So the second premise is also not true, because there are different ways cancer can arise. It's not only based on angiogenesis. And protein taken orally is actually digested and probably will not reach the tumor. So all the premises and the conclusion are not actually true. So this is not a valid conclusion and the argument is not sound. So the third letter is C for comprehensiveness. So the evidence offered in support of any claim must be exhaustive. What we mean by that is you need to consider all kind of evidence, all kind of available evidence must be considered, whether it is with your claim or against your claim. So because it's never reasonable to consider only the evidence that supports a theory and discard the evidence that contradicts it. So for example, let's assume that you're doing a meta-analysis of effect of certain drug on a certain disease. If you exclude the studies with the negative results, of course, you're going to come up with a conclusion in your meta-analysis that supports the drug because you only included the positive studies. So, for example, in the COVID-19 time, if you consider comprehensiveness in any claim, if someone is claiming that remdesivir or hydroxychloroquine treats COVID-19, in order for you to apply this concept of comprehensiveness, you must look at all the different kind of studies, whether they are positive studies or negative studies. So you cannot just look at one positive study and say this drug helps COVID-19. You have to consider why the other studies are negative, what is different about these kind of studies. Is it the population that's different, or is it something wrong with the data or whatever? Okay, so you have to think about evidence that support and evidence that contradicts your claim. Okay, H is for honesty. So the evidence offered in support of any claim must be evaluated without self-deception. This is really important. So when you have examined all of the evidence, it is essential that you be honest with yourselves about the result of the examination. This is especially true for the researchers, the avid researchers who, for example, spend years on certain kind of drugs and they believe strongly about that drug because they worked so much on it. Of course, they will be biased somehow on the side of their previous studies. So it is very important to be honest with yourself, even if you have a very strong belief in certain kind of drugs or therapies or whatever claim. It is very important to be honest with yourself. It could be sometimes that people have very strong belief from religious point of view, and they're conducting a study to prove that treatment is true based on their religious belief. It is important that when you reach the conclusion to be honest with yourself and report the conclusion as is. So if the weight of the evidence contradicts the claim, then you are required to abandon belief in that claim until further studies. R is for replicability. So it is very important in the modern science when you have a positive study is to be able to replicate the results in other studies, okay? Because as we discussed before, when we try to reach the knowledge or the truth, there is only one truth that we believe, and in order for you to reach that one truth, there are different ways. So the ways are different, but the truth should be one. And in order for you to reach that one truth, um, if the study is true, it should be replicable. So you should be able to replicate the findings of that study. So this concept states that if the evidence for any claim is based upon an experimental result, then subsequent experiments or trial will be able to obtain similar results. Many of us remember Wakefield study on the link between autism and vaccines, which has been later on retracted from the journal, and it was found that it included wrong data, etc. And the reason why sometimes studies get retracted and people discover that those studies are wrong is because other people will try to replicate your data. So if you basically come up with fake data, okay, and try to publish it in other journals, believe me, other people will try to replicate your data, and if they don't find that your data is replicable, then they will question your data, and people will come after the data that you published. So it is important that you be honest and the data be replicable. And it is not uncommon, actually, that it's not uncommon usually that researchers actually found that we will have so sorry, I had to interrupt for a few seconds. So back to this slide, replicability. So I was saying that it's not uncommon that you will find a lot of researchers where later on it was found that their academic researchers were actually fraud, and they were not true because other studies could not replicate their findings. So the other letter is for S, which is for sufficiency. This states that the evidence offered in support of any claim must be adequate to establish the truth of that claim with these stipulations. So number one, the burden of the proof for any claim rests on the claimant. In Arabic, we say البينة على من ادعى. So those persons who claim something, they are responsible to give us the evidence for their claims. It's not our own responsibility to prove them wrong. So they need to provide us with evidence that supports their claim. Also, number two, extraordinary claims demand extraordinary evidence. If you are coming up with something that's extraordinary, then the evidence that needs to support that, it has to be extraordinary as well. Number three, evidence based upon authority and or testimony is always inadequate for any claim. Okay, so as we looked previously in the ranking of evidence, testimony and authority, like professors, for example, or experts' opinion, is not sufficient, is not adequate to prove the claim. So why we're doing this approach, the filters, or why do we need to follow a tool to look at claims and address claims scientifically? So many reasons for this, but human beings often try to rationalize and lie to themselves, whether intentionally or sometimes even unintentionally, to prove themselves to be right. Human beings can make mistakes. We have problems with perception and memory. Actually, cognitive bias do exist. There's so many literature on cognitive bias, which we will discuss in the next lecture. Cognitive bias happens even in the best researchers. Something that is true, and it happens, and we need to be aware of. So because of all of these, evidence of any claim should be evaluated without self-deception. It should always be screened for error, for fraud, for appropriateness, and we need to make sure that the cognitive bias are not playing a role in these claims. So I hope that you enjoyed today's lecture as well. Again, please feel free to give me any feedback or if you have any questions, and we will see you again in lecture number 4 next time. Thank you very much.